Instructor Materials Chapter 8 Single Area OSPF CCNA Routing and Switching Scaling Networks v6.0 3 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential Chapter 8 Single Area OSPF Scaling Networks v6.0 Planning Guide. Chapter 8 Single Area OSPF CCNA Routing and Switching Scaling Networks v6.0 18 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential Superscript A 8.1 OSPF Operation. Explain how Single Area OSPF operates. Explain the features and characteristics of the OSPF routing protocol. Describe the types of packets used to establish and maintain an OSPF neighbor relationship. Explain how OSPF achieves convergence. Superscript A 8.2 Varieties of spanning tree protocols implement Single Area OSPF v2. Configure an OSPF router ID. Configure Single Area OSPF v2. Explain how OSPF uses cost to determine best path. Verify Single Area OSPF v2. Chapter 3 Sections and Objectives. 19 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential Superscript A 8.3 Implement Single Area OSPF v3. Compare the characteristics and operations of OSPF v2 to OSPF v3. Configure Single Area OSPF v3. Verify Single Area OSPF v3. Chapter 8 Sections and Objectives. Cont. 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential 8.1 OSPF Characteristics. 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential Superscript A OSPF is a link state routing protocol, open shortest path, first evolution of OSPF 1999 OSPF v3 for IPv6, published in RFC 2740 1998 OSPF v2, updated in RFC 2328 1991 OSPF v2, introduced in RFC 1247 1989 OSPF v1, published in RFC 1131 1988. Development work begins on OSPF 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential Superscript A OSPF uses the Dijkstra shortest path first (SPF) algorithm to choose the best path. Superscript A administrative distance is used in determining what route gets installed in the routing table when the route is learned from multiple sources. The lowest administrative distance is the one added to the routing table. Open shortest path first features of OSPF v2 supports MD5 and SHA authentication. v3 uses IPsec for authentication. Routing changes trigger routing updates. Supports a hierarchical design system through the use of areas. 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential Open Shortest Path First Components of OSPF Database. Let description A, D, J, A, C, E, and C, Y, and E, I, G, H, V, O, R lists all neighbor routers to which a router has established bidirectional communication unique for each router. View using the show IPsp neighbor command. Link state, LSDB. TOPOLOGY lists information about all other routers. Represents the network topology. Contains the same LSDB as all other routers in the same area. View using the show IPsp database command. FORWARDINGROUTING lists routes generated when the SPF algorithm is run on a link state database, unique to each router, and contains information on how and where to send packets destined for remote networks. View using the show iproute command. Superscript A OSPF packet types. Hello, database description, link state request, link state update, link state acknowledgement. 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential Open Shortest Path First Link State Operation 1. Use Hello packets to establish neighbor adjacencies. 2. Use LSAs to flood the area with cost and state of links. 3. Each router builds a topology table. 4/5 each router runs the SPF algorithm resulting in the SPF trees. 6. Each router builds a routing table that includes the path to get to the distant network and the cost to get there. 25/2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential Open Shortest Path First Single Area and Multi-Area OSPF. All routers contained in one area called the backbone area known as Area of Zero, used in smaller networks with few routers designed using a hierarchical scheme. All areas connect to Area of Zero, more commonly seen with numerous areas around Area of Zero, like a daisy or aster. Routers that connect Area of Zero to another area is known as an Area Border Router, ABR. Used in large networks, multiple areas reduces processing and memory overhead. A failure in one area does not affect other areas. The original uploader was Hugo Fett. English Wikipedia transferred from n.wikipedia Commons by Dibuch using Commons Helper. CC by SA 3.0. This URL. Single Area OSPF, Multi-Area OSPF. 26/2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential OSPF Messages encapsulating OSPF messages. Superscript A. OSPF adds its own Layer 3 header after the IP Layer 3 header. The IP header contains the OSPF multicast address of either 224.0.0.5 or 224.0.0.6, and the protocol field of 89, which indicates it is an OSPF packet. Superscript A. OSPF packet header identifies the type of OSPF packet, the router ID, and the area ID. Superscript A. OSPF packet type contains the specific OSPF packet type information. 27/2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential OSPF Messages encapsulating OSPF messages, cont. Superscript A. OSPF v3 has similar packet types. OSPF packet type, packet name description. 1. Hello discovers neighbors and builds adjacencies between them. 2. Database description, DBD. Checks for database synchronization between routers. 3. Link state request, LSR, requests specific link state records from router to router. 4. Link state update, LSU. Send specifically requested link state records. 5. Link state acknowledgement, LSAC, acknowledges the other packet types. 28/2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential OSPF Messages Hello packets. Superscript A. Hello packets are used to discover neighbors, establish neighbor adjacencies, advertise parameters both routers must agree upon in order to become neighbors, and elect the designated router, DR, and backup designated router, BDR, on multi-access networks like Ethernet and frame relay, not serial point-to-point links. Type field 1 equals hello, 2 equals DBD, 3 equals LSR, 4 equals LSU, 5 LSAC. Hello interval, how often a router sends hello packets. Router priority, default is 1, 0 to 255 with a higher number influencing the DR-BDR election process. Dead interval, how long a router waits to hear from a neighbor router before declaring the router out of service. DR and BDR fields contain the router ID for the DR and BDR. List of neighbors is the router ID for all adjacent neighbor routers. 29/2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential OSPF Messages Hello packet intervals. Superscript A. Hello and dead intervals must be the same interval setting on neighboring routers on the same link. Superscript A transmitted to multicast address 224.0.0.5 in IPv4. Superscript A transmitted to multicast address 2 Frank 5 in IPv6. Superscript A sent every 10 seconds by default on multi-access networks like Ethernet and point-to-point links. Superscript A sent every 30 seconds by default on non-broadcast multiple access networks, NBMA, like frame relay. Superscript superscript A dead intervals by default are 4 times the hello interval. If the dead interval expires before the router receives a hello packet, OSPF removes that neighbor from its link state database, LSDB. The router then floods the LSDB with info about the down neighbor. 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential OSPF Messages Link State Updates Superscript A Link State Update, LSU, contains one or more LSAs. LSAs contain route information for destination networks. Superscript A routers initially send Type 2 DBD packets, an abbreviated list of the sending routers. LSDB receiving routers check against their own LSDB. Superscript A Type 3 LSR is used by the receiving router to request more information about an entry in the database description, DBD. Superscript A Type 4 Link State Update, LSU, is used to reply to an LSR packet. OSPF packet type packet name description 1 Hello discovers neighbors and builds adjacencies between them. 2 checks for database synchronization between routers. 3 requests specific link state records from router to router. 4 Link State Update, LSU sends specifically requested link state records. 5 acknowledges the other packet types. LSA type description 1 router LSAs 2 network LSAs 3 OR4 summary LSAs 5 autonomous system external LSAs 6 multicast OSPF LSAs 7 defined for not so stubby areas 8 external attributes LSA for border gateway protocol BGP 9, 10, 11 opaque LSAs 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential OSPF Operational State Superscript A OSPF progresses through several states while attempting to reach convergence. Down no hello packets received. Router sends hello packets in it. Hello packets are received that contain the sending router's router ID 2A used to elect a DR and BDR on an Ethernet link. Extert negotiate master-slave relationship and DBD packet sequence number. The master initiates the DBD packet exchange. Exchange routers exchange DBD packets. If additional router information is required, then transition to the loading state. Otherwise, transition to the full state loading. LSRs and LSUs are used to gain additional route information. Routes are processed using the shortest path first (SPF) algorithm. Transition to the full state. Full routers have converged databases. 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential OSPF Operation Establish Neighbor Adjacencies Superscript A without a pre-configured router ID, RID, or loopback addresses. R1 has a RID of 172.16.5.1 and R2 has a RID of 172.16.5.21234. In its data elect the DR and BDR. 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential OSPF Operation OSPF DR and BDR Superscript A. Why have a DR-BDR election? Superscript A reduced the number of LSAs sent. The DR as the only router used to send LSAs for the shared network. Superscript A reduced the number of adjacencies over a multi-access network like Ethernet. 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential OSPF Operation Synchronizing OSPF Databases Superscript A. After the two-way state, routers need to synchronize their databases and use the other 4 types of OSPF packets to exchange information. 132. 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential OSPF Operation Video Demonstration Observing OSPF Protocol Communications. 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential 8.2 Single Area OSPF v2. 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential OSPF Router ID OSPF Network Topology Superscript A topology used to describe OSPF configuration. 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential OSPF Router ID Router OSPF Configuration Mode Superscript A OSPF v2 configuration uses the router OSPF configuration mode from Global Configuration Mode. Type router OSPF proceed to enter commands. Note there are other commands used in this mode. 39/2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential OSPF Router ID Superscript A Router IDs are used to uniquely identify an OSPF router. Superscript A Router IDs are 32 bits long in both OSPF v2, IPv4, and OSPF v3, IPv6. Superscript A used in the election of the DR. If a priority number is not configured, Superscript A ways a router gets a router ID 1. Configured using the router grid OSPF router configuration mode command 2. If a router ID is not configured, the highest configured loopback interface is used 3. If there are no configured loopback interfaces, then the highest active IPv4 address is used. Not recommended because if the interface with the highest IPv4 address goes down, the router ID selection process starts over. If a loopback address is used, do not route this network using a network statement. 40/2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential OSPF Router ID configuring an OSPF Router ID Superscript A use the router ID XXX is common to configure a router ID. Superscript A use the show protocols command to verify the router ID. 41/2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential OSPF Router ID modifying a router ID Superscript A use the clear OSPF persist command after changing the router ID to make the change effective. Original RID change RID applied RID change. Don't forget this command to make the router ID change effective. 42/2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential OSPF Router ID using a loopback interface is the router ID Superscript A. Older iOS version did not have the router ID OSPF configuration command. Superscript A loopback interfaces were used to provide a stable router ID. Do not advertise this network. It is a common mistake made in OSPF configurations. 43/2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential configuring single area OSPF v2 enabling OSPF on interfaces. Superscript A use the network command to specify which interfaces participate in the OSPF v2 area. Config number router OSPF config router number network XXX wildcard mask area it common misconception. Our 2 has 3 interfaces in area 0, so 3 network statements are used, not 6 network statements for all 6 networks in the entire area. If a single area topology is used, it is best to use area 0. 44/2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential configuring single area OSPF v2 wildcard mask. Superscript A to determine the wildcard mask, subtract the normal mask from 255.255.255.255. Superscript A wildcard mask bit of 0 match the bit. Superscript A wildcard mask bit of 1 ignore the bit. Superscript A wildcard mask is a series of zeros with the rest ones. The zeros and ones are not alternating like an IP address. 24 mask 26 mask. 45/2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential configuring single area OSPF v2 the network command. Superscript A 2 ways to use the network command. Advertise the particular network. Calculating the wildcard mask. Advertise the IP address on the router interface with a 0.0.0.0 wildcard mask. Method 1 traditional method network number and wildcard mask. Method 2 interface IP address and 0.0.0.0. 46/2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential configuring single area OSPF v2 passive interface. Superscript A an interface configured as a passive interface does not send OSPF messages. Superscript A best practice for interfaces that have users attached, Security. Superscript A doesn't waste bandwidth sending messages out OSPF-enabled interfaces that don't have another router attached. Interfaces to configure as a passive interface. 47 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential Configuring Single Area OSPF v2 Configuring Passive Interfaces. Superscript A. Use the passive interface command to configure. Superscript A. Use the show protocols to verify. 48 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential Configuring Single Area OSPF v2 Packet Tracer Configuring OSPF v2 in the single area. 49 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential OSPF Cost. OSPF metric equals cost. Superscript A. OSPF uses the metric of cost to determine the best path used to reach a destination network. Cost equals reference bandwidth interface bandwidth. Superscript A. Lowest cost is a better path. Superscript A. The interface bandwidth influences the cost assigned. A lower bandwidth interface has a higher cost. Interface type preference. Default bandwidth in bits per second. Bandwidth in bits per second. Cost 10 GBps. Ethernet 100 million. Cedula 10 billion 1 GBps. Ethernet 100 million. Cedula 1 billion 100 megabits per second. Ethernet 100 million. Cedula 100 million 10 megabits per second. Ethernet 100 million. Cedula 10 million 1.544 megabits per second. Serial 100 million. Cedula 1,544,064 128 kbps. Serial 100 million. Cedula 128,781 64 kbps. Serial 100 million. Cedula 64,015 62. This is an issue because it is the same cost due to the default reference bandwidth. Needs to be adjusted. 50 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential OSPF Cost. OSPF accumulates costs. Superscript A. The cost for a destination network is an accumulation of all cost values from source to destination. Superscript A. The cost metric can be seen in the routing table as the second number within the brackets. Total cost to reach R to LAN from R1 equals 65. 51 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential OSPF Cost. Adjusting the reference bandwidth. Superscript A. Changing the OSPF reference bandwidth affects only the OSPF calculation used to determine the metric, not the bandwidth of the interface. Superscript A. Use the AutoCost reference bandwidth command to change the OSPF reference bandwidth. Superscript A. Default reference bandwidth is 100 megabits per second. Interface type reference. Default bandwidth in bits per second. Bandwidth in bits per second. Cost 10 GBps. Ethernet 100 million. Cedula 10 billion 1 GBps. Ethernet 100 million. Cedula 1 billion 100 megabits per second. Ethernet 100 million. Cedula 100 million 10 megabits per second. Ethernet 100 million. Cedula 10 million 1.544 megabits per second. Serial 100 million. Cedula 1,544,064 128 kbps. Serial 100 million. Cedula 128,781 64 kbps. Serial 100 million. Cedula 64,015 62. With the default reference bandwidth applied makes 100 megabits per second. Ethernet 1 Gbps. Ethernet and 10 GBps. Ethernet appear to be the same bandwidth within the best path calculations. 52 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential OSPF Cost. Adjusting the reference bandwidth, cont. Superscript A. To adjust to distinguish between 100 megabits per second Ethernet and gigabit Ethernet, use the AutoCost reference bandwidth 1000 command. Superscript A. To adjust to distinguish between 100 megabits per second Ethernet and gigabit Ethernet, use the AutoCost reference bandwidth 10,000 command. Interface type preference default bandwidth in bits per second bandwidth in bits per second cost 10 GBps Ethernet 1 billion Cedula 10 billion 1 GBps Ethernet 1 billion Cedula 1 billion 100 megabits per second Ethernet 1 billion Cedula 100 million 10 megabits per second Ethernet 1 billion Cedula 10 million 100 1.544 megabits per second Serial 1 billion Cedula 1,544,647 128 kbps Serial 1 billion Cedula 128,078 1264 kbps Serial 1 billion Cedula 64,000 15,625 Interface type preference default bandwidth in bits per second bandwidth in bits per second cost 10 GBps Ethernet 10 billion Cedula 10 billion 1 GBps Ethernet 10 billion Cedula 1 billion 10 100 megabits per second Ethernet 10 million 000 Cedula 100 million 110 megabits per second Ethernet 10 billion Cedula 10 million 1000 1.544 megabits per second Serial 110 billion Cedula 1,544,064 77 128 kbps Serial 10 billion Cedula 128,078,126 64 kbps Serial 10 billion Cedula 64,156,250 Auto cost reference bandwidth 1000 command applied Auto cost reference bandwidth 10,000 command applied 53 2016 Cisco and or its affiliates. All rights reserved. Cisco Confidential OSPF cost adjusting the reference bandwidth, cont. Superscript A. If the routers in the topology are adjusted to accommodate gigabit links, the cost of the serial link is now 647 instead of 64. The total cost from R1 to the R2 LAN is now 648 instead of 65. Superscript A. If there were fast Ethernet links in the topology, OSPF would make better choices. Total cost to reach R2 LAN from R1 equals 648. 54 2016 Cisco and or its affiliates. All rights reserved. Cisco Confidential OSPF cost default interface bandwidth Superscript A bandwidth values defined on an interface do not change the capacity of the interface. Superscript A bandwidth values defined on an interface are used by the EIGRP and OSPF routing protocols to compute the metric. Superscript A serial links default to 1.544 megabits per second, and that might not be an accurate bandwidth for the transmission rate. Superscript A used the show interfaces command to see the interface bandwidth. 55 2016 Cisco and or its affiliates. All rights reserved. Cisco Confidential OSPF cost adjusting the interface bandwidth Superscript A. The bandwidth must be adjusted at each end of the serial links, therefore. Superscript AR2 requires its S001 interface to be adjusted to 1024 kb per second. Superscript AR3 requires its serial 000 to be adjusted to 64 kb per second, and its serial 001 to be adjusted to 1024 kb per second. Superscript A note, command only modifies OSPF bandwidth metric, does not modify the actual link bandwidth. 56 2016 Cisco and or its affiliates. All rights reserved. Cisco Confidential OSPF cost manually setting the OSPF cost Superscript A instead of manually setting the interface bandwidth. The OSPF cost can be manually configured using the cost value interface configuration mode command. The no bandwidth 64 is used to remove a command that was previously applied and reset the bandwidth back to the default. 57 2016 Cisco and or its affiliates. All rights reserved. Cisco Confidential Verify OSPF neighbor Superscript A use the show IPSP neighbor to verify the router has formed in adjacency with a directly connected router. Output description neighbor it router ID of the neighbor router priv OSPF v2 priority of the interface used in the DRBDR election process state. The OSPF v2 stateful means that the link state database has had the algorithm executed, and the neighbor router and R1 have identical LSDBs. Ethernet multi-access interfaces may show as two-way. The dash indicates that no DRBDR is required. Dead time amount of time remaining before expecting to receive a hello packet from the neighbor before declaring the neighbor down. This value is reset when a hello packet is received. Address: the address of the neighbor's directly connected interface. The interface on R1 used to form an adjacency with the neighbor router. 58 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential Verify OSPF Protocol Settings Superscript A. The Show Protocols command is used to verify the OSPF v2 process ID, router ID, networks being advertised by the router, neighbors that are sending OSPF updates, and the administrative distance, 110 by default. 59 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential Verify OSPF Process Information Superscript A. The Show OSPF command is another way to see the OSPF v2 process ID and router ID. 60 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential Verify OSPF Interface Settings Superscript A. Use the Show OSPF Interface command to see details for every OSPF v2 enabled interface, especially to see if the network statements were correctly compassed. Superscript A. Use the Show OSPF Interface Brief command to see key information about OSPF v2 enabled interfaces on a particular router. 61 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential Verify OSPF Lab Configuring Basic Single Area OSPF v2. 62 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential 8.3 Single Area OSPF v3. 63 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential OSPF v2 versus OSPF v3. OSPF v3 Superscript A. OSPF v3 is used to exchange IPv6 prefixes and build an IPv6 routing table. Superscript A. OSPF v3 builds three OSPF tables: neighbor table, topology table, and routing table. 64 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential OSPF v2 versus OSPF v3. Similarities between OSPF v2 and OSPF v3. Fedora commands link state. Both are this type of routing protocol routing algorithm. Shortest path first, SPF. Metric cost areas. Both use and support a two-level hierarchy with areas connecting to area 0 packet types. Both use the same hello, DBD, LSR, LSU, and LSAC packets. Neighbor discovery transitions through the same states using hello packets. DRBD function and election process is the same router. ITBF use of 32-bit router ID, determined by the same process. 65 2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential OSPF v2 versus OSPF v3. Differences between OSPF v2 and OSPF v3. FEATURE OSPF v2 OSPF v3 ADVERT ISEMENT SIP v4 NETWORK SIP v6. Prefixes: source A DDRE SSIP v4 source A DDRE SSIP v6. Link local address destination address choice of neighbor IPv4 unicast address 224.0.0.5. All OSPF routers multicast address 224.0.0.6. DRBDR multicast address choice of neighbor IPv6 link local address 2 Frank 5. All OSPF routers multicast address 2 Frank 6. DRBDR multicast address advertise networks configured using the network router configuration command. Configured using the IPv6 OSPF persisted area ID interface configuration command. IP unicast routing. IPv4 unicast routing is enabled by DEFAULT. IPv6 unicast forwarding is not enabled by default. Use the IPv6 unicast routing global configuration command to enable authentication plain text and MD5 IPv6 authentication, IPsec. 66 2016 Cisco and or its affiliates. All rights reserved. Cisco Confidential OSPF v2 versus OSPF v3 link local addresses superscript A. An IPv6 link local address enables a device to communicate with other IPv6 enabled devices on the same link and only on that link, subnet. Packets with a source or destination link local address cannot be routed beyond the link from where the packet originated. Superscript A IPv6 link local address are used to exchange OSPF v3 messages. 67 2016 Cisco and or its affiliates. All rights reserved. Cisco Confidential Configuring OSPF v3 OSPF v3 network topology superscript A. Be sure to turn on IPv6 routing and assign IPv6 addresses to interfaces before enabling OSPF v3. The FE80 address on each router represents the link local address assigned to each router. 68 2016 Cisco and or its affiliates. All rights reserved. Cisco Confidential Configuring OSPF v3 OSPF v3 network topology, cont. Steps to configure OSPF v3. 1. Enable IPv6 unicast routing in global configuration mode. IPv6 unicast routing. 2. Optional, configure link local addresses. 3. Configure a 32-bit router ID in OSPF v3 router configuration mode. Router IDRID. 4. Configure optional routing specifics such as adjusting the reference bandwidth. 5. Optional, but optimum, configure OSPF v3 interface specific settings such as setting the interface bandwidth on serial links. 6. Enable OSPF v3 routing in interface configuration mode. IPv6 OSPF area. 69 2016 Cisco and or its affiliates. All rights reserved. Cisco Confidential Configuring OSPF v3 link local addresses superscript A. Verify IPv6 addresses on interfaces. Superscript A. Remember that link local addresses are automatically created when an IPv6 global unicast address is assigned to an interface. However, IPv6 global unicast addresses are not required. Link local addresses are required for OSPF v3. Superscript A. Unless configured manually, Cisco routers create a link local address using FE8010 prefix in the EUI64 process by manipulating the 48-bit Ethernet MAC address. 70 2016 Cisco and or its affiliates. All rights reserved. Cisco Confidential Configuring OSPF v3 assigning link local addresses superscript A. Manually configuring link local addresses make it easier to manage and verify OSPF v3 configurations. Use the IPv6 address link local interface command to apply. Use the show IPv6 interface brief command to verify. 71 2016 Cisco and or its affiliates. All rights reserved. Cisco Confidential Configuring OSPF v3 configuring the OSPF v3 router ID superscript A. Use the IPv6 router OSPF persisted global configuration command to enter router configuration mode. Superscript A. Use the router IDRID command in router configuration mode to assign a router ID, and use the show IPv6 protocols command to verify. Same process as OSPF v2. 72 2016 Cisco and or its affiliates. All rights reserved. Cisco Confidential Configuring OSPF v3 modifying an OSPF v3 router ID superscript A. Use the clear IPv6 OSPF persist privileged exec mode command after changing the router ID to complete the router ID change and force the router to renegotiate neighbor adjacencies using the new router ID. Original router ID. Change the router ID. Complete the router ID change. Commonly forgotten step. 73 2016 Cisco and or its affiliates. All rights reserved. Cisco Confidential Configuring OSPF v3 enabling OSPF v3 on interfaces superscript A. Use the IPv6 OSPF area interface configuration mode command to enable OSPF v3 on a specific interface. Ensure the interface is within an OSPF area. Superscript A. Use the show IPv6 OSPF interfaces brief command to verify. 74 2016 Cisco and or its affiliates. All rights reserved. Cisco Confidential Verify OSPF v3 Verifying OSPF v3 Neighbors Superscript A. Use the show IPv6 OSP neighbor command to verify neighbor connectivity with directly connected routers. Output description neighbor ith router ID of the neighbor router prith OSPF v3 priority of the interface used in the DRBDR election process state the OSPF v3 stateful means that the link state database has had the algorithm executed and the neighbor router and R1 have identical LSDBs. Ethernet multi-access interfaces may show as two-way. The dash indicates that no DRBDR is required. Dead time amount of time remaining before expecting to receive an OSPF v3 hello packet from the neighbor before declaring the neighbor down. This value is reset when a hello packet is received. Address the address of the neighbor's directly connected interface the interface on R1 used to form an adjacency with the neighbor router. 75/2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential Verify OSPF v3 Verifying OSPF v3 Protocol Settings Superscript A. Use the show IPv6 protocols command to verify vital OSPF v3 configuration information. 76/2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential Verify OSPF v3 Verify OSPF v3 Interfaces Superscript A. Use the show IPv6 OSPF interface command to display a detailed list for every OSPF v3 enabled interface. Superscript A. The show IPv6 OSPF interface brief command is an easier output to verify which interfaces are being used with OSPF v3. 77/2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential Verify OSPF v3 Verify the IPv6 routing table Superscript A. Use the show IPv6 route command to see an IPv6 routing table. Superscript A. Use the show IPv6 route OSPF command to see just the OSPF v3 routes. 78/2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential Verify OSPF v3 Packet Tracer Configuring Basic OSPF v3. 79/2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential Verify OSPF v3 Lab Configuring Basic Single Area OSPF v3. 80/2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential 8.4 Chapter Summary. 81/2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential Conclusion Packet Tracer Skills Integration Challenge. 82/2016 Cisco and/or its affiliates. All rights reserved. Cisco Confidential Superscript A. Explain how Single Area OSPF operates. Superscript A. Implement Single Area OSPF v2. Superscript A. Implement Single Area OSPF v3. Conclusion Chapter 8 Single Area OSPF